going to prove the law of cosines. Essentially what this law is, it helps you to be able to compute a third side of a triangle when you only have two sides and the enclosed angle. And what that enclosed angle, and so what that means is, for instance, here we want to find out what side A is, but all we know is side B, which is over here, and we have side C over here. And we know what the cosine of this angle is right here. So in other words, if I had a triangle like this, and we have here is A, and we have angle A over here, and we have B, and we have angle B over here, and we have C, and we have C over here. So if all I knew right now was this and this, then I could compute how long that is. Okay, so first thing I do in being able to prove that is to construct the altitude for this triangle of ABC. As you can see right here, I've tripped that. And of course, an altitude is from the vertex down to the base, and it's be perpendicular to the base. So I restate the given, the triangle ABC, and that segment BD is perpendicular to AC. Next, we know from this triangle right here is that after constructing that, we have C squared is equal to H squared plus X squared. And we know that is because of the Pythagorean theorem. And now all I do is just solve for H, and obviously just move the C over here, which becomes a negative, and the H goes over there. So we have to change the signs, and so we have H squared equals C squared minus X squared. And next I do the same thing on this side. Now we have A squared here, A squared, which is the hypotenuse of this side over here, okay? A squared is going to be equal to this side right here of B minus X, parentheses squared, plus H, which is the same thing, again, using the Pythagorean theorem. And then I just solve for H squared, and it gives us A squared minus parentheses B minus X squared. Now I do substitution. I take this and put H into each one of these places, and so here we have solved for H over here, and therefore this is X right here. So H comes over here, and so I just made a substitution of that into this equation right here, which we have here, and then by combining these terms right here, I will go ahead and it becomes a C squared minus X squared equals, because it's 2A squared, and then it's B squared, and then it's 2 plus 2A, 2BX minus X squared, and that's to be in by substitution, and also of combining the like terms. Then I go ahead and solve for X from this for A squared, and by doing that, we move the A to this side. We're going to change the signs of both sides, and that's going to end up being an A squared equals B squared minus C squared minus 2BX, and that's again by combining like terms. Next, we know what the cosine is. The cosine of A is the adjacent over the hypotenuse, which means that's going to be, erase that, that's going to be, the cosine is going to be X over C, which is that, and so therefore we're going to solve for X when we just cross multiply, and when it was C cosine A. The next thing, we just take this X, substitute that into this equation we had originally up here on step 5, and then we end up with A squared equals B squared plus C squared minus 2BC cosine A through a substitution, which is exactly what we have just proven, is that we know if we know one side, two sides, and the enclosed angle A, In other words, right here we know B and C, and we know the enclosed angle of A, then we can find out what A is, and we have just proven that.